Hello, Mr. Mailer here, online math teacher, and welcome to my channel. Today we're going to be kicking off my video series on confidence intervals. So if you find this video helpful, consider smashing that like button, subscribing, and let's go. So, confidence. You are confident when you think you will succeed. So we want to talk about confidence within the context of statistics. So here is a scenario. A student at a large university wants to study the GPA of full-time enrolled students. This student takes a simple random sample of 72 full-time enrolled students and finds that the mean GPA of these students was 2.9. So the question, based on what we've recorded here, that this student must be wanting to answer is, what is the true mean GPA of full-time enrolled students at this large university? So he's interested in learning about this parameter, and we denote that with mu because it's the population mean, the true mean GPA of these students. So, but that's a hard question to answer. At a large university, it's not going to be realistic for this one student to go and poll everybody what their GPAs are. That would be a census, and that's hard to carry out. So what this student did is he took a simple random sample of 72 full-time enrolled students and found that their mean GPA was a 2.9. So he did this. And like we have here, the population parameter here, this population mean, is unknown. However, when he takes his simple random sample of 72 students, we do know his sample statistic here. But the reason we ask ourselves these questions about an interval is we can take our sample, but is this sample mean equal to the parameter of interest, this true mean GPA for all these full-time enrolled students here? And the answer is no. So the sample mean is probably not equal to our parameter of interest, although there is the very small possibility it could be, but we assume it isn't. But the better question we can ask is, based on the sample mean we obtained of 2.9, what are reasonable values our parameter of interest mu might actually be? And for this, we can construct a confidence interval. So the general idea is our sample we use to serve as a point estimate to kind of anchor where we're going to construct our interval around. So since our sample mean was a 2.9 GPA, on my interval I drew down here, I'm going to put it right here. So this is 2.9, and that is called a point estimate. So your statistic, your sample statistic, is called a point estimate when you're constructing confidence intervals. And depending on how confident you want to be that the interval you're going to construct around your point estimate will capture what this population parameter we're interested in is, you will widen or narrow your interval. So maybe I want to be very, very confident that my interval is going to capture the parameter of interest. In that case, I might say, well, if I go about half a GPA point in either direction away from my point estimate of 2.9, so what this provides me with is an interval of likely values that my population mean could take on. Now, if I'm not confident that this interval will capture what the actual population mean is, so the actual mean GPA, I can widen the interval of interest. Maybe I extend one GPA point above a 2.9 and one GPA point below a 2.9. So that would move the endpoints of my interval to a 1.9 and a 3.9. But so you can adjust how wide your interval is based on how confident you want to be that your interval will capture the actual true mean GPA here. So let's just stick with my interval here of 2.4 to 3.4. When I write this, I will always take the convention of not including my two endpoints because things start to get a little bit more iffy at there, but we'll take any value in between these. The last thing I want to mention in this video is how wide you make your interval, how, in particular, how far apart each of your endpoints is from your point estimate is something we call the margin of error. So the way I constructed this, I know that the distance between my point estimate and each of these endpoints is 0.5. So I would have the same thing on either side. So this is a confidence interval in this case with a margin of error equal to 0.5. Now, when we get into technically creating these intervals, depending on how confident you want your solution to be, we will be able to find specific numbers to associate as our endpoints. But this video is just to give you the idea of what a confidence interval is. Your sample statistic is very likely not going to equal your population parameter. So in this case, the true mean GPA. So we cast kind of a net or an interval of values around our point estimate, which gives us a reasonable values that could be our true parameter of interest. So this true mean GPA. So I hope you found this video helpful. Come back in the next video and we'll talk a little bit about confidence level as well as what confidence intervals really mean.